excited to be here to talk to you about Nexus and the future of durable execution across team and namespace boundaries. As Preeti mentioned, joined by Rob and Roey. So, we'd love to chat, so please come find us after the talk. And just to kind of recap what we saw in the keynote, when you have multiple services in an app and they're backed by Temporal, the question becomes, how do they communicate? And does that support durable execution in the way that you would want? And we mentioned that before you could do child workflows or activity wrappers, and those have notable limitations and so forth. Workflows, a leaky abstraction. Child workflows, have to run in the same monolithic namespace in Temporal Cloud, kind of defeating the purpose of having multiple namespaces. And activity wrappers, a lot of boilerplate, second-class observability. You still have to craft those bespoke APIs, and at the end of the day, you still have to ask yourself that question. Does it support durable execution in the way you would want, with integrated observability and execution debugging, asynchronous, synchronous operations, completion results, all that stuff. So with Nexus, you get this integrated temporal experience where you can use that temporal SDK to spin up those Nexus handlers in your existing workers, and you can expose those clean service contracts up through the Nexus endpoints, which are like API proxies, and you create those using the Nexus API registry in Temporal. And what this is basically, in the open source, that's a cluster-scoped API registry. You can think of it as a control plane for creating these endpoints and spinning those up and managing them. And in Temporal Cloud, that API registry is scoped to your account across all the namespaces there. And so, since we use the same Q-based worker architecture that you're already using for your workflows and your activities, you get automatic load balancing for free. And then also, we have built-in retries with an exponential backoff for Nexus requests and automatic circuit breaking. And then fully integrated observability, like we mentioned before. And this is all available both in the open source and in Temporal Cloud. But Temporal Cloud basically has a global MTLS secured envoy mesh that connects all these namespaces together. And what that enables us to do is to route Nexus requests across namespaces, across regions, across clouds, with support for GCP coming in the future. And then we're also able to control access as part of that fabric and do things like saying this caller namespace is allowed to use this Nexus endpoint. The service is on that Nexus endpoint. This is all available today in public preview, and it's ready for production use cases. You can check out our launch stages doc, and it talks about we're offering formal support for this. We basically have these API stability. We're going to try and avoid to make breaking changes there before we go to GA. And we have support for the Go SDK today, Java SDK as a fast follow, and the other SDKs in the GA timeframe. And so this is available both in the open source and in Temporal Cloud. And we have a really rich roadmap. And this is not a comprehensive roadmap. I'd love to chat with you, but just some highlights here. So external calls. So today, with Nexus, you can use Nexus services from a caller workflow inside of that temporal context. And you might ask, well, why can't I call it from an external client? Why can't I call it from my web server backend or even the actual browser app, SPA? And so we want to support that, and that would basically involve exposing endpoints from Temporal Cloud externally so that those clients can access that. But that also then ties in with, well, it's no longer just a caller namespace that's calling this Nexus operation. It's an external client, and so we have to bring in additional authentication in terms of establishing a caller identity, a Nexus identity, and things like this. And those can still be secured in the same ways that you might otherwise authenticate with your namespace, whether it be MTLS client certs or API keys or JOT tokens or what have you. We also want to support open source to cloud communication, and this is also including for things like migration. If you're migrating from open source to cloud, being able to migrate one namespace at a time, one Nexus endpoint at a time, with no downtime, and making that work. And then across organizations, you might have a large org with different BUs, or you might have partners that you're working with. And so enabling durable execution across those boundaries. And then also just better protocol support for whatever you might be using in terms of HTTP or gRPC and different frameworks that you might like to use. And then having a really great API-first developer experience, where we have gRPC-like protos that you can use with CodeGen to provide an even better developer experience around Nexus, and then being able to publish those IDL definitions up into the API registry so that you can have a rich browsing experience and understand how to use the service without having to manually document everything. And maybe even in the future some more insights and even breaking change prevention and those types of things that you can do once you have that schema registry in place. And then also just more advanced controls. So like an API proxy can have multiple upstream targets. We support a single upstream target today in the Nexus endpoint, but in the future, you can imagine Nexus endpoints that aren't just billing or shipping, but are more like prod west or prod east. And that I have 100 services behind that endpoint, and so I'm gonna need to be able to route individual services to different namespaces and task queues, different upstream targets. And then also if I have all these different callers using my shared service, well, I kind of want to do rate limiting on a per caller basis, and so having finer grained rate limiting there, authorization on a per service or per operation basis, and even things like per endpoint payload encryption. So we really love your feedback. Please come find us after the talk so that we can help prioritize this, because this is still early days for Nexus, and we got a long road ahead of us. So with that, I want to invite Rob up on stage from Netflix to talk about how they're using Temporal and Nexus. So Rob.
Hi, so I'm going to talk a little bit about how we are using Temporal at Netflix. Internally, we first started with converting Spinnaker, our CI/CD platform, to use Temporal to increase our reliability with cloud operations. And then we moved on to delivery workflows, and it's organically grown across the company to orchestrating our Open Connect appliances, which is a global CDN across the world. Well, yeah, it's global. Our cloud infrastructure, doing persistent and real-time data infrastructure, cloud compute abstractions, doing CDO content and data management, as well as security use cases, both corporate and platform, and then much, much more. And as we've been building, there's been an increasing desire for teams to collaborate across different namespaces. And right now, that's kind of a challenge, because you have to do activity wrappers, as people have said before, and that involves a lot of boilerplate. And if you don't want to do that, it's opening up an entire namespace to another team, and that introduces a lot of security risks. So this leads a lot of teams to just not deal with it. They use large monolithic namespaces, and it's just not ideal. So what we really want is a Temporal native service contract. Some way to increase cross-team and cross-use case collaboration without having lots of boilerplate, and also be able to manage the security characteristics and ensure that only the right things are being exposed to people that want to interact with your system. One such use case is a product that I work on, which is called Infra API. It's a internal cloud platform. You can kind of think of it as the AWS for Netflix. We have multiple clouds inside of Netflix, all built on top of AWS, including EC2 and Titus. And it's a Kubernetes API control plane without the scheduling. So we don't run pods, replica sets, or anything like that. But what we do have are tons of CRDs that represent different abstractions and resources inside of Netflix, and hundreds of thousands of resources, and probably next year, millions upon millions. What we really like about Kubernetes is that you have a single global API contract. You don't need to learn how one team has decided to implement their control plane and then implement something completely different for another control plane. You just have a single way of interacting with and discovering anything inside of the Netflix infrastructure. And we also like the federated ownership of these control planes, not having to contribute to a single application, but it comes with a lot of problems when we're dealing at our scale. Kubernetes is not really designed to have hundreds of thousands or millions of resources. We've gone through pretty heroic efforts to scale Kubernetes to this scale. And even so, the people that are interacting with our platform don't really like it because of the large complexity that Kubernetes has when you're writing a controller. What people really prefer is the procedural programming nature of Temporal, and so that's what we kind of want to lean into with Infra API. So through Nexus, we are able to kind of take a step back and redesign our system so that it's temporal native front to back. We're kind of exploring, do we keep the Kubernetes API contract or not? But that's kind of an implementation detail. But instead of having to use this level set reconciliation loop, you can now have control planes opt into a similar Kubernetes model or have operation-based reconcilers. And Infra API will continue to hold the state, federate the APIs, and then dispatch events to these control planes using Temporal Nexus. So what this will kind of look like is up at the top, some system comes in and says, I want to create a thing, and it will store the desired state inside of Infra API, and we will use a dispatcher workflow, which is currently a small workaround until external clients are supported with Temporal Cloud for initiating Nexus operations. And we make a call into this demo namespace. And as it, the Nexus operation will trigger a signal with start workflow, and that's an entity workflow that just lives for as long as this Flunder resource exists. And it just kind of hangs out in a loop, and as needed, it will call out to Infra API to get the desired state, and as needed, update the observational state, which if you're familiar with Kubernetes is basically the status. And how that looks as a practical example is through this time series database abstraction, which we have. And each one of these boxes would be a controller in and of itself with its own desired state. So someone comes along and says, I want to have a time series database. They write it into Infra API, and the first thing that will be created is the time series database resource. It needs to call out to Cassandra, another database abstraction layer for key value, and then also Elasticsearch. And those then fan out to creating all the network things like security groups, load balancers if they need them, creating the server groups, and those cascade down further to either AWS or Titus. And that's a decision that the Cloud Compute Abstractions team can make as a runtime decision. Sometimes they might decide that the workload is best in Titus as a containerized workload, or maybe you'll be using actual VMs. And this is something that is kind of just abstracted away from you. I know this was kind of a real quick crash course, but I'm very happy to talk about this more after the talk if you're interested in exploring why we're choosing to go about this direction. And now I'm going to pass it off to Roey to talk about how it works internally.
Thank you, Rob. I'm Roey. I was the lead engineer on this project for the last year. Yeah, and I'm here to tell you about how it works and a little bit how you might use Nexus. Oh, there we go. All right, so you have two teams, and Team A has developed some useful workflows, and Team B wants to call these workflows, right? But Team A doesn't necessarily want Team B to call workflows directly. There are some implementation details when you invoke a workflow, like which task queue it's served on, how you construct an idempotent workflow ID or retry policies and timeouts. All these are implementation details, so you want a better contract, right? So Team A goes to our docs, and they discover that we have something called Nexus, right? So with Nexus, you can define a service abstraction that will hide all these primitives from your callers, right? So what is a service? It's essentially a named collection of operations. And these are arbitrary duration operations that you can author with the Temporal SDKs. All right, so this is an example of an operation. It's a synchronous operation. And you can see that it actually looks very much like an RPC handler, right? It has an operation name, it has inputs, it has outputs, and because you're using the Temporal SDK, we'll also inject a initialized client for you that you can use to, for example, query a workflow. But you're not limited to just querying workflows. You can actually do your database call or anything you would do with an RPC handler in your normal application. Now, this is where it gets a little bit more interesting. What if you have an asynchronous operation that could last, let's say, months, right? That you can't express that as a single RPC. So there's a bit of magic, I guess, that kind of goes on here. So the SDK does a lot of heavy lifting for you, but we have a construct that lets you expose a workflow as a Nexus operation. And you basically get to map the input and options that you get to how you would start a workflow. Then once you've created these operations, you register them with the service, and you register that service with your temporal worker along with the rest of your workflows and activities. And now you're ready to share this service with Team B, right? But how do they actually use the service? Well, you don't really want them to have access to this namespace and task queue, and it kind of breaks the abstraction, right? And that's what a Nexus endpoint is for. So a Nexus endpoint essentially is a named resource. It's unique if you're in Temporal Cloud for your Temporal Cloud account. If you are a self-hosted user, it'll be unique for your cluster. And essentially, it tells Temporal how to route requests for that endpoint. So it says, OK, if I get a request for this specific endpoint, the payments endpoint, I have to go to a specific worker that's polling on a namespace and a task queue. And in Temporal Cloud, we also have this allow list policy. So you can say Team B can actually access this endpoint, right? If you're a self-hosted user, you can build custom authorization rules using the authorizer that we offer. And lastly, there's a description in Markdown form that you can basically tell your users how you would consume this endpoint and what services are in it, right? So that's basically where Team A's work is done. And now Team B needs to call the service. And that's very simple to do. We have a utility within the workflow package in the SDK that you can create a Nexus client for a given endpoint, a given service. And then essentially all you need to know is what is the operation name, what are the inputs and outputs, and you can specify how long you're willing to wait for that operation to complete. And as you can see, the caller has no idea that they're calling a workflow or what this operation is backed by. Nice, so we know how we use it, but how does it actually work? So this is all backed by an open RPC protocol that we've developed. As you can see, it's in a separate GitHub organization, and it was mentioned before that Temporal actually uses Nexus RPC under the hood. And it's essentially a set of abstractions on top of HTTP that allow you to model these arbitrary duration operations. We also mentioned that we built this completely open, so we hope that other companies might adopt this, and we'll be able to integrate Temporal with external systems. Right, so back to your application. So what we saw is essentially you have the caller side, which is a workflow. You have a handler that we kind of seen what that might look like in code. And then you have the temporal service that runs your application. It could be the same instance of the temporal service. It could be separate instances. And then your application essentially will use typically temporal primitives to power itself. Right, but your application needs workers to actually run. And if you're interested to know more about SDKs and workers and how that works, there's an in-depth overview of SDKs by Spencer from the SDK team. Tomorrow, I highly recommend going to that talk. But back to the application. So the caller workflow, essentially, when it wants to execute a Nexus operation, it instructs the worker to do it on its behalf. And your worker, once it realizes that all the coroutines in this workflow are blocked, it realizes that it needs to complete the current workflow task. And it tells the temporal service the workflow wants to schedule a Nexus operation. And this is now made durable by the temporal service in the form of a history event. And the durable machinery that is responsible to convey this request to whatever the handler side is now kicked off. So the way that it works is that we look up in the API registry, we figure out where we need to dispatch the request for the specific endpoint. And we have a bunch of functionality in this machinery. So we have circuit breaking built in, we have rate limiting built in, we have automatic retries and backoffs. All this happens under the hood, and this is where the synchronous RPC happens. This is where we use the Nexus RPC protocol. On the handler side, we also use the registry to resolve this endpoint to find out which worker to dispatch this request to. And the worker essentially pulls on a new type of task queue, which is the Nexus task queue. So once this request gets translated into a Nexus task, your worker will find the registered operation handler for this specific task and call your code. So if this was the synchronous operation that we saw before, your application will just send a query workflow request, for example, to the temporal service, right? So then the response from that function is delivered back to the worker, which gets delivered back to the handler temporal service. And the handler responds to the caller. At that point, the completion, the result of this operation is stored in workflow history. And because there's progress in this workflow, we dispatch a workflow task to notify your code. All right, so eventually the worker will pull and get notified of this new workflow task and will deliver the result to your code and unblock a specific feature in this workflow that's started the whole process. Right. On the caller flow workflow, you will see that there are two new history events. There's a Nexus operation scheduled and a Nexus operation completed event with the inputs and the results. But what about an async operation? So if we're back to the SDK now is dispatching to your operation handler, if it's a workflow operation, then essentially what the SDK will do is on your behalf, it will request to start a workflow, but this workflow actually has a couple of new attributes on it. It has links, and it has a callback. And you can see that in the UI. So essentially, this link is a link to the history event, the Nexus operation scheduled history event on the caller workflow. And the callback is essentially, how the result of this workflow needs to be delivered to unblock the caller workflow. Right, so in this diagram, the response is asynchronous. So instead of giving back the result, we give back an operation ID that then later can be used to cancel this operation, and when we have client calls, you'll be able to also get the result or get information about this operation using this identifier. And the difference here is that instead of a completion event, you will have a started event. So the caller workflow history will look like this. Right, so the handler workflow eventually runs to completion, and the callback is delivered with the same reliability as the actual start operation request. The handler workflow will see that the callback was delivered. This is viewable in the UI. And on the caller workflow, you'll see two things. Actually, something that I left out in the operation started, you'll also see a backlink to that workflow that backed the operation. And now in the completion, you will see the Nexus operation completed event. So that was it. We're very excited to be sharing this with you. We'll be hanging out on the Temporal Slack, on the Nexus channel. We'd love for you to try it out. We'd love to get your feedback. Every bit of feedback is very valuable for us at this stage of the project. And this is a reminder that Nexus is in public preview right now, is ready for production use cases. We've worked on this for a bit over a year, and just 3 or 4 months of that year was just validation and stress testing in different scenarios. So we're feeling very confident for you all to be using this in production right now. And please get started today at this link. Thank you very much.